Okay, so we'll start now with naming aromatics. Aromatics are group, it's like a big group of organic compounds. And characteristics of aromatics is that they are cyclic. So they are cyclic. They have somehow a cyclic structure in within their structure, and they are unsaturated. Remember what we said about the unsaturated one? Unsaturated. When they are unsaturated, that means that they have at least one double or triple bond. So the most simple aromatic is benzene. And the structure of benzene is something like this. We have an hexagon, and at the corners of the hexagon, we have carbon, and the carbon, and then, of course, we have hydrogen that are connected with it, with each of them. But then on alternated bonds, we have a double bond. So this is the structure of the benzene. However, what we have to keep in mind is that the evidence are indicating that those bonds between carbons are equal in length and strength. So what is happening? The electrons that are forming those bonds are moving from one single bond to double bond, from single bond to double bonds, and so on. And what do we see is actually a mix of the two possible structures. Is the one that we just draw, so it's an hexagon in which the bonds are like this, or another one that looks like the bonds are switched. So still we do have an hexagon, but now is like this. Okay, so in order to represent this possibility of the double bonds into the structure of benzene, what we do is we represent it as an hexagon with a circle in the middle, showing or indicating that the double bonds are moving from one bond to the other. Okay. This is known as the resonance structure. You don't need to know this. It is outside the scope of the course for Physics 30. However, when we see just this, then we name it as benzene. And now let's see, how will we name it if we have one branch or more than one branch. So let's suppose that we have this as a structure, as a line structure. So we have a benzene, and in one of them, what we see is methyl, and in the other one we see an ethyl. So this will be the line structure. Okay, so the way that we name it, we start with labeling or numbering the carbons. So we'll start with 1, 2, 3, 4, 5, 6. I started with ethyl. The branch here is ethyl, because this is before M, which is the other branch that is methyl. So the first branch is ethyl, and then when we name it, same as we do on every single aliphatics, we go the position of the branch, then dash, the name of the branch, ethyl, dash, the position of the other branch, 3, not 2, 3, dash, and then the name of the other branch, methyl. Its E goes before M alphabetically, and then the main ring or main chain is benzene. Okay, so 1 ethyl, 3 methyl benzene. Now let's see a case where the branch let's see a case when the benzene ring is part of the branch. So let's suppose that we have the longest continuous chain, the longest continuous chain is having more than 6 carbons on it. Then if we see a branch that is benzene, then that is not the main chain. Okay, then the benzene as a branch will be called phenyl. Okay, so let's suppose that we have this as the example. We have a chain that has 1, 2, 3, 4, 5, 6, 7, even 8. Okay, so and then here we have methane. Here we have another one, and here we have benzene ring, and here we have an ethyl. Okay, so let's label it. As we see here, the benzene ring is part of the structure. However, when we count carbons, then we have 1, 2, 3, 4, 5, 6, 7, 8 as the longest chain. Okay, we can even go the other way here, but it will be the same thing. So even if we go here, will be the same thing. Okay, so let's start numbering the longest chain. We can start from left to right or from right to left. We'll start numbering carbons with the first one to see the first branch. So if we start numbering carbons as 1, 2, 3, 4, 5, 6, 7, 8, then the first branch will be on number 3. But if we start numbering it as 1, 2, 3, 4, 5, 6, 7, 8, then the first branch will be on number 2, which is methyl. And here is methyl as well. Since now this becomes a branch, then we call it phenyl. And this one here is ethyl. So obviously the correct labeling will be with the red one. Okay, so now let's start labeling it alphabetically. The first letter in the alphabet is E, so will be the location of the branch, which is 6, then ethyl, then we move M is before P, so will be 2, 3. Since we have 2 methyl, then we'll go dimethyl. And then on the 5th dash, on the 5th, we have phenyl. And we have octane, since we have 8 carbon. Okay. So I will draw 2 more examples here, and then we will try to number them. I will just stop the video for a second. So let's suppose that we have something like this. Let's number the carbon chain. We'll start with numbering it to the first alphabetical branch, since the benzene ring is the main chain, because we see it here has 6 chains, and then all those have 2 or 3 carbons on it. So will be 1, 2, 3, 4, 5, 6. So on the first and the second, we have ethyl as the branch. And on the third, we have methyl. So when we name it, then we will have something like 1, 2 diethyl, and then dash 3 methyl benzene, since it is the longest chain. Okay, I will draw another one, and then we'll do more examples in class. So let's suppose that we have this as a structure now, and we start first numbering carbons. We notice that we have a double bond here, so a double bond has to be in the main chain, and we notice that benzene ring is as a branch, so this will be phenyl. And then the numbering will start 1, 2, 3, 4, 5, 6. The first one, the closest number of numbering the carbons should be on the double. So double has to be the first one. And then we have another branch here, which is methyl. And now let's label it. So we have 2 on the second place. We have 2 methyl, and then on the 4th one we have phenyl, and then we have 6 carbons, so hexane, since it is double bond. Yeah, so sorry, we have to state as to where is the double bond, sorry. So this will be hex for 6 again. So if we go 2 as the first alphabetical branch methyl, then on the 4th we have phenyl, and then we have 6 carbon chain, so 6 for hex for 6, and then we'll say the double bond is on the first place, and then will be N. Okay, so we will see more examples like this in class, and that will be clear. So first you identify the longest chain that includes the double chain. In this case, the numbering of carbons will start to closest to the double chain, label the branches, and then identify in which place is the double chain. Okay, so this concludes the aromatics. We'll move to hydrocarbons derivatives.